Hey everybody, Mr. Grove here. Today we're going to talk about your osmosis lab a little bit and try and get you set up for completing that. So on the Monday-Wednesday group, I collected your final mass data, and that is shared on Google Classroom here. So you can see what those are and then get that written in for your own data tables. So I've given you the final masses, and then to get the change in mass, you will take the mass final minus the mass initial, and that will give you the change in mass. And that needs to be left negative if it's negative. So we would expect some of the potato change in masses to be positive, so they gained mass, and then some of them to be negative, that they lost mass. So change in mass would be final minus initial. Then to get the percent change in mass, we're going to take whatever this change was, divide it by the initial, and then times it by 100. And the same goes, if it was a negative number, leave it negative. And if it was a positive number, leave it positive. You should have some of both, okay? And so that would be how you get the change in mass and the percent change in mass. Final minus initial, and then the change divided by the initial times 100, leaving the negatives if you have them. Once you've got your data completed for both the sugar water and then also the salt water, then we can move on to the graph. The salt numbers might be a little messier, maybe not quite as consistent with graphic kind of data. And that's okay. We would kind of expect that a little bit based on the size of the salt molecule. So once you get the data all completed though, then we'll go and you'll need to make a graph that looks something kind of like this. Since we have positive and negative numbers, we can't just do our traditional x-axis and then y-axis going up. We have positive and negative y values. The x, everybody should be the same. So you're going to be 0, 5, 10, 15, 20, and 25, because these x values will be the concentration of the cups themselves, and everybody used 0, 5, 10, 15, 20, and 25 for the percent concentration of your cups. For the y value, that's going to depend a little bit on what your biggest number was. So you'll have to kind of figure out how you want to calibrate that. If your biggest number was like 32, then maybe you should go 5, 10, 15, 20, etc. And then down here would be negative 5, negative 10, negative 15, negative 20, etc. as well. Okay. If your numbers weren't that big, then you could maybe go make your increments smaller, like 2, 4, 6, 8, 10, 12, 14, 16. If they were even bigger, you might have to make them 10, 20, 30, 40, 50. So again, that's going to depend a little bit on your data. Once you get that, then you can put your points in. So what was your percent change in the 0? Let's say it was 23%, and so we've got it here on 5. So if that would be 25, that means we'd have a point about right here for 23. And then our next one, maybe that would be, let's say it was negative 2%. So the 5% concentration, negative 2, so maybe a point about right there. And then maybe the next one was negative 11% change in mass. So we'd put one about right there. For the 15% cup, maybe it was like negative 12% change in mass. So we'd put one maybe about right there. 20%, maybe it was negative 20. And 25%, maybe it was negative 22. So we'd have data that kind of looks like that. And then what we're going to do is make a best fit line. So a best fit is kind of an average between everything.
Waiting for bus 30 or 33, please go down to the gym.
And so that average then is just kind of a best fit through all that. So you want to kind of move that to where it kind of represents stuff on both sides of the line. Where that crosses the 0% mark, that's going to be the isotonic solution. And so that, wherever that concentration is, that's how we would answer these questions, what the percent concentration of the potato and what the percent concentration of salt in the potato would be. using your two different labs or your two different graphs, one for sugar, one for salt. So that's kind of how you graph it. That's how we answer this concentration question for the salt and the potato. I will tell you, your graph for the salt is probably going to be a little bit less quality. The numbers are going to maybe be here and there everywhere. Because when we think about the size of salt ion, sodium is only 23 grams per mole, chlorine is 35.5 grams per mole. That is way smaller than a sugar molecule, which is sucrose, which is 342 grams per mole. So this, remember, size determines how easily something can move in and out of the cell membrane. And that's what we were doing when we created our solutions and our potato. So kind of think about that as you answer your questions on that. Speaking of the questions, so, why are the potato cores changed in mass on day 2? And, why would you have positive, negative numbers? See if you can label which of the solutions you would have called hypertonic and hypotonic. Why do you think we use percent change in mass rather than the just change in mass? Did the salt data give you good data, or was it not as good as the sugar, or was it better than the sugar? What controls did you have in place? And you could think of that, or what controls / constants, if you want to think of it as that. And what errors could have had for the lab. Okay, so those are your questions. You can add those to your lab packet somewhere, and hopefully that was helpful. Email me with any questions.